Alright, so lesson 315, another lesson where I think I'm going to be jumping around quite a bit, so I'll try and remember to pause the video. So, using transformations to create polygons. In lesson 314, you practiced reflecting, rotating, and translating polygons. Since these were rigid transformations, the image always had the same angle measures and side lengths as the original. In this lesson, you will combine the image with the original to make new, larger polygons from 4 basic building block polygons, which are these 4 right here. So the Shape Factory. The Shape Factory, an innovative new company, has decided to branch out to include new shapes. As product developers, your team is responsible for finding exciting new shapes to offer your customers. The current company catalog is shown at the right. Since your boss is concerned about production costs, you want to avoid buying new machines and instead want to reprogram your current machines. The factory machines cannot only make all the shapes shown in the catalog, but are also able to rotate or reflect shapes exactly one time. For example, if the half equilateral triangle right here is rotated about the midpoint, which would be the middle of the line segment, of the long side is shown at the right, you get a rectangle. So your task, your boss is giving your team until the end of this lesson to find as many new shapes as you can. Your team's reputation has suffered recently from a series of blunders, could really benefit from an impressive new line of shapes formed by a triangle and its transformations. Each of the triangle in the catalog determine which new shapes are created when it is rotated or reflected exactly one time so that the image shares an entire side with the original triangle. Be sure to make as many new shapes as possible. Use tracing paper or any other reflection type tool. I will say, normally I'm not a huge fan of tracing paper, but I definitely think it comes in super handy in this lesson. Having said that, it's pretty difficult to do with a video, so I will not. So what I would do is, I guess we'll focus on this half equilateral triangle, and since they had already started with that, I'm going to go ahead and just sort of clear everything else out of the way except for that half equilateral triangle, and give myself some room to work with to kind of tell you what they're expecting you to do. So there's reflections and rotations. And really, because it's a triangle, you can only do 3 each. And when they reflect, they're saying you have to reflect on the side. You can't reflect on the angle and do something like this. They don't want you to do something like that. You have to, if you're going to reflect, it has to be a shared side. So, I think this will be, I'm gonna be in for it as far as being able to do this, I think, because I'm gonna keep deleting what's behind. Anyway, so what might make sense is, what if I reflected across this side? I would get something that looked like this, and you can see what I would have would be an isosceles triangle. So one reflection would give me an isosceles triangle. And again, I'll try and erase this, but I don't like my chances. Yeah, there we go. So frustrating. Okay, what if I, apologize for this. Yeah. Okay, what if I reflected across this one? Again, you can see I would get another isosceles triangle, so I already have that written down, so nothing too dramatic there. What if I went across this side? Well, across this one here, if I reflected this way, we'd already talked about this. This would be a rectangle. So let me go ahead and delete this first, and then I will type in a rectangle. This might be better. Obviously, I should have typed reflection and rotation. All right, so done with that one. We've done all 3 reflections from each side, and this is what we came up with. Now the rotations. What if we rotated, and now again you have to rotate across the midpoint of a line segment, so that would mean that this would rotate up. Well, I hope you see that again, if we rotated from there, we would get another rectangle, which we already have a rectangle there. So I guess it's the same rectangle, but at least we got this one with the rotation, so I guess we can kind of keep track of the fact that that happened. What if we rotate from here? What would it look like if we rotated from there? And this gets a little bit tricky, but this went down, that went up, that went up, that went down, this went down and to the left, this will go down and to the left. I hope that we see that point would go there, and we would get something that looked like that. So now we know these side lengths are the same and these side lengths are the same, so it looks like we're getting a parallelogram, right? Or a squished rectangle. So we can go ahead and mention that we have a parallelogram. And I think we did that one and that one. So what happens if we did the same thing here? Again, it's a little hard for me to visualize too quickly, but they went right, so we go right. This went left, so we go left. This went right and up, so this would go right and up. So it would be something like that, and we would just get another parallelogram. It would look different, but we can see that we have another parallelogram. So that's what we get just from this one shape. So let me pause where we're at. Well, I don't know. Actually, I'll pause in a minute. I want to bring some of this stuff back here. So we did, that went a little too far. Okay, so we did the half equilateral triangle. I rotated it on all three sides, and I reflected it on all three sides, and I rotated it on all three sides, and these are the shapes that I got. Well, the expectation is that you would go ahead and you would do that for the other three shapes as well, which I will not do that. I'm going to pause the video and just kind of talk about what we would have learned once we rotated and reflected all three of these. It looks like if you go through all the shapes, these are the shapes you can get by reflections: a square, a right isosceles triangle, a rhombus, an isosceles triangle, a kite, and a dart. We had already found isosceles triangles, I think. I think we thought we found a rectangle. Maybe we didn't. Anyway, for rotations, we had a rhombus, a rectangle, a parallelogram, and a square. It makes me think that we screwed up and it was actually a rhombus shape and not an isosceles rectangle. I don't know. Whatever. Long story short, this is the shapes that the book is saying that you should be able to get. So if we jump back over to the lesson, the next thing it asked us to do was some stuff. I usually skip problem 353. But they wanted us to build a catalog. It says your boss now needs you to create a catalog page that includes your shapes. Each entry should include a diagram, a name, and a description of the shape. List any special features of the shape, such as sides, same length, equal angles, etc. Use color and arrows to highlight these attributes in the diagram. So what we would have done is we would come up with like this basic shape page, and I didn't actually usually have you guys mark this up too much because we're going to do something else with this in lesson 316, but this is the basic shape page. I hope we know some things about it, like that regular hexagons, that means it's a regular shape, so all the sides are the same length, all the angles are the same. Like a kite, these two sides are the same, and these two sides are the same. A rectangle, of course, these are the same, and these are the same. The opposite sides. Scalene triangle means all the sides are different, etc. So, but again, we were going to do something different with this basic shape thing in lesson 316. So I don't usually have my kids mark it up in 315.